We are solving question 34 of 2012 GATE Chemical Engineering paper. Heat is generated at a steady rate of 100 watt due to resistance heating in a long wire. Length is 5 meter and diameter is 2 mm. The wire is wrapped with an insulation of thickness 1 mm that has a thermal conductivity of 0.1 watt per meter Kelvin. The insulated wire is exposed to air at 30 degrees Celsius. The convective heat transfer between the wire and the surrounding air is characterized by the heat transfer coefficient of 10 watt per meter square Kelvin. The temperature at the interface between the wire and insulation is. So, in this question, we have been given a long wire whose length is 5 meter and diameter is 2 mm. So, let's just consider this as the wire where diameter is 2 mm, that is 2 into 10 raised to minus 3 meter. Length we have been given as 5 meter, and this wire is wrapped with an insulation of thickness 1 mm. So let's consider this as an insulation, and the thickness we have been given as 1 mm. That is, we can write this inner diameter dis 2 mm and outer diameter will become d0 as 4 mm. The insulated wire is exposed to air at 30 degrees Celsius. That is, the outer temperature is 30 degrees Celsius. And then we have been given this thermal conductivity. The wire is 0.1 watt per meter. The insulation is 0.1 watt per meter Kelvin. And the heat transfer coefficient H is 10 watt per meter square Kelvin. And we have to find the temperature at the interface between the wire and the insulation. So here, that is, here we have to find this temperature Ts at the surface of the wire. Now let's draw the resistance diagram. So if Ti is the temperature of the wire, and the temperature of the wire will remain uniform, so it will be the same at the surface. So let's just call it as Ts. So throughout the wire, the temperature will be Ts, and then we have the insulation, and due to insulation, we will be having a conductive resistance. That is R1. Then we'll be having the convective resistance, that is R2. And the outer temperature we have been given as 30 degrees Celsius. Now the overall heat balance, we can write it as Q is equal to Ts minus 30 upon R1 plus R2. Now R1 we can write it as R0 minus Ri upon K times log mean area, and ALM, that is a log mean area for the cylinder, we can write it as A0 minus AI upon ln of A0 upon AI. So area we can replace it as 2 pi RL. For outer it will be 2 pi R0 L, and for inner it will become 2 pi RIL. So, and we can cancel this 2 pi L, and in terms of radius we will be in terms of radius we can write this as 2 pi L. So we have taken this 2 pi L as common, R0 minus Ri upon ln of R0 by Ri. Now we can put this value of ALM over here, and we can get the radius as R0 minus Ri upon K times of R0 minus Ri ln of r naught upon ri, and we also have this 2 pi l. This r naught minus ri will get cancelled out, and the r1 we will be having as ln of r naught upon ri upon 2 pi kl. That is the conductive resistance within cylinder. You can straight away remember this formula. Now R2, so let's just calculate the numerical value of this term also. So R1 will be ln of R0. The outer radius is 4 by 2, it will become 2 mm, and the inner radius will be 2 by 1, that is 1 mm, on 2 into pi is 3.14. The value of K thermal conductivity we have been given as 0.1 into length is 5 meter. So you can solve this and you will get the value of 0.2207. It is R1. The conductive resistance is 0.2207. Similarly, the convective resistance R2, we can calculate it as R2 is equal to 1 upon H naught into A naught, where in H naught we have the value as 10. The outer surface area is 2 pi R naught L, that is we can write it as 2 into 3.14. The outer radius is 2 mm, 2 into 10 raised to minus 3 into length of 5 meter. And you can solve this, and the final value of this outer radius will be 1.592. So we have this resistance R1 and R2, and now we will be putting into this heat balance equation, that is Q is equal to T, temperature at surface, minus 30 upon R1 plus R2, and Q we have been given as 100 watt. So 100 is equal to Ts minus 30 upon R1 we had 0.2207 plus R2 we have 1.592. So from this we can get the answer as Ts upon 30 upon 1.8127. You can solve this for Ts, and you will get the temperature at the surface as 211.27 degrees Celsius. So the final answer is 211.2 degrees Celsius. That is option A.